Hello and Assalamualaikum to all my friend and today I will present about acid and base. What is acid? An acid is a substance that releases H plus ion in an aqueous solution. Aqueous means water. Example, when hydrochloric acid is dissolved in water, the compound separates into chlorine ion, Cl negative, and hydrogen ion, H plus. There are two types of acid. The first one is strong acid and the second one is weak acid. A strong acid breaks down completely in water and gives off many H plus ion, and a weak acid only partially break down. It gives off much less H plus than a strong acid. The characteristic of acid: it contains hydrogen, have sour taste, and react with metals and carbonates to produce gas. These are a few examples of acid. First one is hydrochloric acid. Second one, sulfuric acid, nitric acid, carbonic acid, acetic acid, citric acid, phosphoric acid, and oxalic acid. As you can see, it has H in the chemical formula. The second one is taste sour. Acid in food tastes sour and produce a burning or prickling feeling on skin. How dangerous acid is? Since tasting or touching an unknown chemical is extremely dangerous, other methods are need to tell whether solution is an acid. A safe way to test to see if solution is an acid is to place a few drops on a compound that contain a carbonate, CO3. Example, limestone is a rock that contains calcium carbonate, CaCO3. When an acid touches a piece of limestone, a reaction occurs that produces carbon dioxide gas. And lastly is react with metals. Acid also react most metal. The reaction produces hydrogen gas, which you can see as bubble. Next, we go through about what is base. A base is a substance that releases hydroxide OH negative ions in an aqueous solution. Example, when sodium hydroxide NaOH is dissolved in water, the compound separates into sodium ions, Na plus, and hydroxide ion, OH negative. As you can see in the picture, like acid, base has three of characteristics. The first one is contain hydroxide ions, OH negative. The second one we have bitter taste, and third one is feel slippery. This is a few example of base: lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, calcium hydroxide, barium hydroxide, calcium hydroxide, and lastly strontium hydroxide. These are the few examples of bases. Base. Mild base in food tastes bitter and feel slippery, but as with acid, tasting and touching are not safe way of testing whether a solution is a base. In fact, some strong base can burn the skin as badly as strong acid. Base feel soapy or slippery because they react with acid molecule in our skin called fatty acid. In fact, this is exactly how soap is made. Mixing base, usually sodium hydroxide, with fatty acid produce soap. So when a base touches your skin, the combination of the base with your own fatty acid actually make a small amount of soap. These are properties of acid and bases. Acid has taste sour. do not feel slippery. pH under 7, release hydrogen ions in aqueous solution, corrode metals, react with metals to produce a compound and hydrogen gas, and turn litmus into red and pink or pink. The bases tastes bitter, feels slippery, pH is more than 7, release hydroxide OH negative ions in aqueous solution, do not corrode metals, do not react with metals to produce a compound and hydrogen gas, and turn litmus into blue. Acid-base strength. pH stands for potential hydration and is a measure of how many H+ ion there are in solution. The strength of an acid or base is usually measured using a pH scale. The more hydrogen there are, the lower the pH will be. This is a scale of pH. The more hydrogen there are, the lower the pH will be. So you can see the lowest pH scale is 0 and the most highest is 14. The number of pH scale usually range from 0 to 14, but numbers outside this range are possible. The middle number 7 represents a natural solution. A natural substance is neither an acid nor a base. Pure water has a pH of 7. When an acid and base react with each other, the characteristic properties of both are destroyed. This is called neutralization. Example of neutralization: an antacid tablet contains a base such as sodium bicarbonate, magnesium hydroxide, or calcium carbonate. The base react with the stomach acid and produce a salt and water. This reaction lowers the acidity and raises to pH its normal value. This reaction lowers the acidity and raises to pH to its normal value, about 2. In conclusion, industrial use for acids and base are inevitable and needed because they come in a wide array of forms, are used to purify materials, and are needed to maintain the functionality of a majority of our planet. So that's all for now, and bye.